Right, good evening everybody. As mentioned, my name is Jacques from Westhuizen, longest name in the business, I'm sure. And as mentioned as well, I am a mechanical building services engineer working for a company called JDP. I didn't always want to be an engineer. In fact, up until about 4 years ago, I didn't even know what building services engineering was. Ever since I can remember, I've always been interested in how things work. This curiosity started for me as a child. I always enjoyed remote control vehicles. However, my father would never buy me any because I'd always take them apart to see how they work and never be able to put them back together. I finished my high school in South Africa, where I'm originally from, and then moved over to the UK to look for some new opportunities. I started my career as an engineer at a small engineering firm based in Oxfordshire, who manufacture automation machines for the packaging industry. I started there in the workshop. I started in the workshop there, using big CNC machines and lathes to make parts. I then moved to the fitting workshop, where I took those parts I made and I put them together to make an assembly, which in the end I made a machine from. And from that I was then progressed into the drawing office, where I started to design machines from my experience that I've worked up in the workshop. Following my apprenticeship, I moved to a different company and a different engineering sector through someone I met at college, into building services engineering. I work for, like I say, I work for a company called JDP, and with them I've been very fortunate that I've been able to work on various projects all over the country, really, ranging from small to large, from schools to health and well-being centres to offices. In fact, in one of my latest projects, which was a shopping centre in Gloucester, right underneath the shopping centre was a vault, and in that vault was a what's going on here? Was a Roman wall, which we had to protect. We had to provide ventilation to it, remove all the humidity from the area. So this is one of the things I enjoy most about my career, is that it's never the same thing. You're never in the same place. You can go to a shopping centre and find a Roman wall sat under the floor. So I've, since being with my company, I've completed my building services degree at London South Bank University, and I'm currently studying for a master's at Brunel University in the hope of becoming a chartered engineer. I'm currently on the committee of the CIBSE Young Engineers Network, CIBSE standing for the Chartered Institute of Building Engineers, and YEN being the Young Engineers Network. And I am very active in the London constituency. So, as I'm sure, does anyone here know what a building services engineer is or does? There's a couple, it's good. Well, let me start by saying this, is everyone comfortable? Can you see me okay? Can you hear me? So yeah, you're welcome. That's exactly what we do. So what I'd like you to do is to imagine yourself in the most extravagant building, something like the Marina Bay Sands in Singapore. Now, take away all the lights, take away all the heating and ventilation, take away the lifts and the escalators, acoustics, plumbing, power, and all the security systems. And basically you're left with a dark shell that's uninhabitable and no one wants to be in. So what building services engineers do is we bring buildings to life. So we basically install we design, install, all the equipment that would make this building function the way you understand a building to function. There's a very good example there. I always like to explain to people building services engineers are a bit like surgeons. We deal with all the organs and everything that make the human body work, whereas the structural guys, they're the skeletons. They make it stand up. I won't talk too much about the civils. Then you have the architects who make it look nice, like the old plastic surgeons. So, as a building service engineer, we work closely with other sectors of engineering, like, for instance, structures. We work with completely different sectors like architecture. We work directly with clients to get the idea of what they want for their building into fruition. And these are all the sorts of things that you would be needing to consider as a building services engineer. The best thing about my job, like I said, is it's never the same. It can be office-based, or you can be on site. Like Georgia was saying, she was in Bedfordshire this morning, and tomorrow she's somewhere else. It's a very, very similar thing. One day you're in the office designing something, tomorrow you're on site shouting at a contractor to get him to do what you want him to do. So typical tasks include sort of producing designs, whether that's 2D or 3D. We use computer software to calculate thermal modelling of buildings to understand how much energy is required to make this a comfortable space for you to be in, how much energy it's going to take for that building to be comfortable, and then we can start looking at improving that to make it a comfortable space but keep it as energy efficient as possible. And then you'll be out on site, you'll be watching people install these things, you'll see your designs that you've put down on paper come to life like something you've never seen before. It can be quite stressful. Buildings cost a lot of money, and if you make a mistake, then the client's not going to be very happy with you. Which then brings me to sustainable designs. Historically, building service engineers designed and installed services. Whereas now, with the whole climate change and everything that's going on in the world today, our effect on the environment is becoming noticeable to us. And as part of a building services engineer's job is to try and make buildings more sustainable. We try to use more sustainable equipment. We deal with architects to orientate buildings, to shape buildings, to minimize energy, or to gain as much natural resources as we can, like sunlight or wind or anything like that, that we wouldn't need to actually use energy to make the building work. And that's sort of a good example there of where building services engineers have influenced designs from architects or structural engineers to help shape buildings so that you wouldn't need any mechanical or electrical equipment in that building to make it more comfortable. It's all passive. It's called passive design. So all these passive design features is something that we all need to work very closely with architects and the other team members with. We basically work to a system of being lean, being clean, and being green. And basically, we influence the structure of the building, so we try to include for high-performance thermal elements. So, as we all know, in your houses, everyone's talking about loft insulation and cavity insulation, all that stuff, so maybe a little bit our fault. But yes, so that's what forces that through. Then we look at the type of energy that we use. So rather than using grid-supplied electricity to heat water or natural gas to heat water, we use systems that are big power plants, like the Olympic Park has a big power generation centre which produces both heat and power by a big gas-fired engine, and it's called district heat networks, so you can run hot water all along in that entire area, and people can just take hot water from it because it's a lot more efficient to to make it in bulk than it is in the small things that like your house boiler or whatever. And then lastly is to use renewable energies, so things like photovoltaics or wind power, or you get geosource heating and cooling and all that sort of cool things, which I won't go into too much. But this is all stemmed from the government who, in 2008, declared that by 2050, the UK will reduce its energy by 80%, which is a lot. But the way the world has used energy has caused an effect that we've gone past the point of no return. We can no longer be where we were before. The only thing we can do now is limit our effect on our environment. And this graph just shows if we carry on doing nothing, our global temperature is going to go up by 4 degrees. But that doesn't sound terrible. 4 degrees is not that much warmer. It's probably 4 degrees warmer in the air than it is out there. But this graph here, or this table here, shows you what could happen when things change by 4 degrees in the world. I won't go through it in too much detail, but if you sort of start looking at this first column, there's some minor things starting to happen, there's some disease, there's some species dying. Well, we're okay with that, apparently. So the world has said we're going to try and limit our energy or our increase to the temperature to 2 degrees. Because if you start looking what's happening past the 3 degree change, there's some major change happening in the world. And the reason why us as building services engineers are so focused on reducing energy is that nearly 50% of the energy used in the UK comes from buildings and the mechanical and electrical services that drive them. 18% of that comes from domestic, so our houses. But it's not all bad news, because there is a plan on how we can change this. So how are we going to achieve this 80%? Well, what we need to do, we need to halve the amount of energy we use. We need to double how efficient the equipment is that uses energy. And then we need to improve the carbon offset of the energies that we do use. And by doing that, we can achieve 80%. And we are currently about there, and we're sort of on track. At the moment, we're about 30% reduction, so we've still got a long way to go. And hopefully, with more innovation from these young guys that are sat up here, and myself and you guys, then that's a target that could be achieved. Like I said, it's not all bad news. You can see the trend is going down. We are using energy more efficiently. However, we do tend to use more energy as technology tends to develop. But we all need to do our part in order to sort of try and change the world. So my contribution to this was as part of my dissertation for my university degree. I looked at some sustainable insulation materials to help improve our housing stock, because like we said, 18% of all the energy we use in the UK comes from our houses, and they're all old houses, a lot of them. They just sat there, and they'll probably sit there for the next 50 years. So what we've looked at is we looked at waste production. And one of these things is chicken. We all eat a lot of chicken. Currently in the UK, they produce 200 tons of chicken feathers a week. And this is just a byproduct. And currently, some of it's being used in cosmetics. Some people use it in concrete mixes. There's this thing starting to come up in diapers. But most of it ends up in landfill. They also use it, small amounts of it, for something called feather meal, which is a low-grade food for animal feed. So a startup company from the Imperial College London called Aero Powder produced this insulation material made from waste chicken feathers. And as part of my dissertation, I investigated the the viability of this material for use as building insulation. And I also did a comparison to commonly used insulations today, and I also carried out a embodied carbon assessment. So for those of you who don't know what embodied carbon is, it's the amount of energy that's gone into producing a product from its inception to its end, but then converted into carbon using carbon factors. I've got, for instance, electricity. To convert 1 kilowatt of electricity, 1 kilowatt hour of electricity to carbon, to kilograms carbon, you have to times it by 0.517, I think. But then the same for gas, it's 0.2, so that the electricity currently has a higher carbon penalty than what natural gas would have, for instance. But so most of the energy in the UK is currently measured in carbon. So what this product showed is that it produced 16.3 megajoules of energy per kilogram, which converts to 3.24 kilograms of carbon per, 0.6 kilograms of carbon per kilogram of the material. I compared that to other materials. So this product was called Featherfill. The other products I compared it to was Thermofleece, EPS, which is expanded polystyrene, and Rockwool. So Thermofleece is a natural fibre made from sheep's wool. Rockwool is a mineral fibre made from like rocks. It's pretty simple, it's in the name, but it's made from ceramic. Sorry, that's the word I was looking for. And based on my assessment, the embodied energy of the feather product was better than any of the others because it's a waste product. You lose a lot of carbon because it's already been produced by another process. And also looked at the thermal conductivity, which is something as a building services engineer you'll get to learn much about. It's basically the rate of heat transfer through a material. And as an insulation material, you want that to be as low as possible. And from that figure, you can see that it also performs better than the samples tested from other materials. So that sort of brings me to my end. I think I'll now just tell you about the institution that I'm here representing tonight, which is the CIBSE Young Engineers Network. They're a network that helps bring young engineers together in situations where they could feel more comfortable asking questions or running ideas by each other. So up here I've got what the YEN network tries to achieve, and the crux of it is that they try and encourage young engineers to speak to more professional engineers to gain experience and to improve their knowledge. The young engineers, they provide a forum and support for these engineers to come. We do social events, network events, technical events, site visits, and all these things to try and help and encourage young engineers that don't always have the opportunity to experience things out in the real world. And just to be there, someone to be able to talk to. There's many CIBSE YEN institutions all over the country and also internationally. This information is all available on the CIBSE Young Engineers Network, and we've also got the CIBSE Young Engineers Chair here tonight. So if we'd like to chat to her. But yeah, that brings me to my end. So I encourage you all to work hard. It's not easy studying. I did my route to where I am now quite different to the other guys. Like I said, I started as an apprentice. I've done all my studying part-time whilst working, but there are some very good benefits to that as well. Everything that I've been learning, I've been able to apply the next day. My company pays for my studies. They give me the day off to do that. So there are definitely opportunities out there, and you need to grab them and put in the hard work, and hopefully you can be an engineer that might change the future one day. So yeah, good luck.